So in this case, we are going to consider as a continuation working with the core functions, which is our core ratios. Remember our previous case that we had, we managed to refer to the reduction, working with the positive and negative angles. So in this case, let us see what we are having as we got our core functions, which is our core ratios, which is simply taken from the complementary concept. So this is from the complementary. Remember, if you're talking of complementary angles, these are two angles which add up to 90 degrees. Two angles. Let's say one of the angles is here, it's A, and this one, it's B. In a right angled triangle, we know that these angles, they add up to 180, all of them. So subtracting this 90 degrees from 180 degrees, we are going to have what? 90 degrees, which is remaining. Meaning to say that these two angles that are remaining, A and B, they are supposed to add up to 90 degrees. These two angles, they're supposed to add up to 90 degrees. So as they are supposed to add up to 90 degrees, we can write one angle in terms of another. What am I trying to say? A plus B is equal to 90 degrees, these two angles that are remaining. So it means if I want to calculate B, I can simply make that be the subject. B is equal to, I take the A to the other side. So it's going to be 90 degrees minus A. The same concept, guys. Let's say I wanted to calculate A. I was going to take B to the other side. So it is going to be 90 degrees minus what? Minus B. So let's talk of one angle there, which is theta. Let's talk of theta. All right. A and B, we have this concept. It's fine. Let's talk of theta. Let's say one of these angles is theta. One of these angles is theta. Let's say it's theta here or whatever that you have. Let's say one of these angles is what? Is theta. What is going to be the other one? Guys, from the same concept, if I have one angle, the other one is going to be 90 degrees minus A. If I have B, it's going to be 90 degrees. Let's say this was B here and this was A. A was going to be 90 degrees minus B. But where B is, we are talking of what? Theta. So it means this other angle that we are seeing here was going to be 90 degrees minus theta. If one is theta, the other one is going to be 90 degrees minus theta from this concept. So using this concept, we are saying these two angles, they are complementary. If we add these two, we are supposed to get 90 degrees. If we take this theta, we add to the 90 degrees minus theta. So as you can see, guys, we are going to get what? 90 degrees. So this is the complementary concept. So what does it gonna do? Why is it gonna play a role in our simplification? The core function concept is stating that we can have a certain ratio, and that ratio will be written as a core ratio, as a corresponding complementary function. To say if it is theta, all right, if we talk of the theta, the corresponding is what? 90 degrees minus theta as the complementary. We are saying it is just like we are given 50 degrees. What is the complement of 50 degrees? The angle that when we add here, we are supposed to get 90 degrees. That is the complement of what? Of 50 degrees. It means the complement there is going to be what? 40 degrees. 90 degrees minus 50 degrees, which is 40. That is the complement of this one. If we add these two, we must get 90 degrees. So what does it mean? It means that if I have this one as 50, this other angle was just supposed to be 90 degrees minus 50. 90 minus 50. If I have this one as 40 degrees, I can do the same thing. This one is going to be 90 degrees minus what? Minus 40 degrees. So what is the concept of these angles? I want us to see what is going to happen for these two, for 90 degrees and what and theta. Let's say we have got those ones, 50 and what and 45 and 40 degrees, the one that I just had now. I want us to see their properties so that we can conclude very soon. I'm just going to conclude this part of our co-functions. It's nothing there. It's not like there's much there. So let us just quickly have this part. So I want you to see something in terms of the presentation. Let's just say we have sine of what? 50 degrees. I want you to see something here. Sine of what? 50 degrees. Sine 50 degrees. All right. It's 0.766. Sine of what? 50 degrees. It's 0.766. What about the cos of this one? So we want to change sine to a cos, right? I'm going to talk about that. All right. So let's find cos of 40. I want you to see something there. Cos of 40 degrees, 0.766 again. So as we can see, the cos of 40 degrees is giving us the same answer as of the sine of 50 degrees. This is the condition of our co-ratio concept. From a certain ratio to the corresponding co-ratio, we are supposed to obtain the same answer. We are supposed to have the same value. It is going to be affected by the issue of the quadrants, to say where is it that the quadrant lies. We're going to talk about that one later on. So when I'm saying a ratio and a co-ratio, this is the concept, guys. Let us just list them here. A ratio to its corresponding co-ratio. So it means if you are given a ratio of a sine of theta, all right? We talk about, let us just talk about its ratio, not like in simplification. We just need to talk about this sine changes cos, the co-ratio cos, all right? So if it is cos, it's going to be sine. If we talk of a tan, it changes to a cot. That's the co-ratio. If it is given as a cot, it changes to a tan. This is the concept that you're going to be doing in your simplification. If it is a sec, it's going to change to a cosec. A cosec is going to change to a sec. So as we can see, there's a core concept there. Sine, cos. On cos, you remove the core. So you remain with what? Sine. Are you seeing the concept? If the core is already there, you must remove it, the core. If it is not, if you don't have that core, you must put that core there. All right? Like here on sine, we don't have, so you put the core there. So it will be what? Cos. The cosine, it's cos. Cosine. Are you getting the sense, guys? Here, the core is already there. So we remove it because it's already there. So it will be what? S, sine. Remember, when you say cos, it means cosine. So we're going to remove the core. We remain with what? With a sine. So this is the concept. When you have a tan, as you can see, the core is not there. So you put that core. So it will be what? Cot. Cotangent. Cot. Remember, tan is tangent. So it will be cotangent. Core there. It's not there. So you put the core. If it is not there, you put it. If core is there, you remove it. So as you can see here, there's a core. So if we cancel the core, what do you remain? Tan. Cot means cotangent. So if you remove the core, there it will be what? Tan, which is a tangent. Sec, there is no core there. So you put that core. So it will be what? Cosec. This is it, cosec. On the other side. Here, there's a core. So you remove the core to get what is there. So you remove this core here. So what do you get? Sec. Sec. If you remove the core, you get the sec. So this is the concept of the core function. Where the core is, remove it. You get what is that part on the other part. Where the core is not there, you put that, you get the equivalent. That's how you can know their equivalent in an easier way. That's how you can know this in an easier way. Then another thing that you need to know about these co-ratios or co-functions, it follows that the ratio that will be given to say it's your original ratio. The ratio, when I'm saying a ratio, that's the original one. The co-ratio is its corresponding part, which is from the complementary function concept. So it follows that if a ratio where it lies, let's say the ratio lies in the first quadrant, and in the first quadrant, we know all ratios are positive. It follows that the core ratio, the corresponding part, which is the complementary part, which is there for the core ratio, also it must be a positive. So the golden rule is the sign of the ratio is the sign of the core ratio. All right, let me have it here. So it must be our golden rule, this one. So it must be our golden rule. All right. So I'm simply saying here the sign of what? Of, if you consider to say you are dealing with a ratio. So the sign of a ratio is also the sign on the what? On the co-ratio. It's very, very important. So if it is a negative, it must also be a negative. So we are going to talk about others which are related to these, because guys, we're not going to talk about these ones only of 90 degrees minus theta. There are other functions of the complementary which are of the same nature that you see in the form. Once you see this 90 degrees minus theta from the complementary, so they work with the same concept, like remember how we take our angles. It's 0, 90, 180, 270. So this one at 90 degrees, it is corresponding to this one at what? 270. So these angles, all of them, they can be taken here. These I'm going to list them. So they will be taken this way. Remember previously how we took our angles so that we don't confuse each other here. I was saying the acute angle is taken between what? The reference or the horizontal. It depends if it is this side, the negative horizontal, if it is this side, the positive horizontal, and what? The line that you're given between the angle. But in our case, our theta is not that way. Our theta, it will be here. It will be between the vertically now and the angle and that line, because we are talking about 90 degrees. 90, as you can see, guys, we are related to that 90 and 270. That is our reference now. Previously, any other angle was being taken along this one, the 0 degrees. But now you'll be using 90 and 270. So your angles, they will be like this. From 90 degrees, you'll be having an acute angle here, which is our theta. From 90 degrees, you'll be having an acute angle from 90 degrees. So as you can see, this one is just going to be a continuation, remember, like this, so that we consider the vertically opposite angles. This one will be also 90 degrees along. So you do the same thing with this one. It will be what? 90 degrees. So we are using this time the vertical as our reference where we have 90. So it means our angles will be referred from that 90 degrees. All right. So in the first quadrant, this is the angle that we are going to be talking about, not this theta. We'll be talking about this angle in between here, this one, in the first quadrant. And that angle is going to be 90 minus theta. Remember, the whole of this angle is what? 90 degrees. So this one will be 90 degrees minus theta. So this is the angle that we are talking about, 90 degrees minus theta. All right. So in the second quadrant, the angle was supposed to be like this in the second quadrant. Remember our angles now, the way that we from this one, from the 0 there, we're going to take our angle like this up to here. So as you can see, this angle, it is going to be what? 90 degrees plus theta. Theta is involved, this one. You're going to count in that 90 degrees. So meaning to say, in our second quadrant, our angle is supposed to be what? 90 degrees plus. We have to count that one. It's plus theta this time. All right, plus theta. All right, so this is, all right, sorry for that. Need this one. Remember I said 90 degrees minus what? 90 degrees minus theta. All right. So in the third quadrant, the angle is this one. Remember, this is 270 degrees, this one. So out of 270, we're just going to remove this theta. We talk about the whole of this angle from here. Let me take this one. From the positive horizontal axis here up to where we meet this line here. This is our angle. So out of the 270 degrees, this one, we are simply going to remove this theta. So it will be 270 minus theta. So in that quadrant, our angle is 270 degrees minus theta. So as we can see in the fourth quadrant, we are now adding theta to 270 because we are moving from here like this to the fourth quadrant. As we can see, theta is included. This is what? 270 degrees. Then theta is also part which lies in the what? In the fourth quadrant. So it's included in this 270. So it's 270 degrees plus what? Plus theta, just like that. So these are the angles, how you're supposed to take them. So in our presentation of the core functions or the complementary functions, we are talking about any angles or functions which are presented in this format. 90 degrees minus theta, 90 degrees plus theta, these formats. So like I said, when a ratio is positive, its corresponding co-ratio is positive. So this is what I'm trying to say. You figure out what is happening. Remember, this is your first quadrant. All, whether it is about the co-ratio, the concept is about reduction to have an acute angle at the end. We are supposed to have it as an acute angle. Theta is still an acute angle. Is still an acute angle. It is still an acute angle. It is only the presentation where it is presented because we are focusing with where 90 degrees. So we focus with what? The vertical. So this is how we take our angles. But theta is still what? An acute. So we are still going to use the reduction angle concept. But that reduction angle concept in writing of an angle of theta, not to say we are going to take it the way that it was here to say, all right, this is the 360 degrees minus theta. What is going to happen? We have that concept in mind, but we are having what? These angles in mind. Only that. We are having only that in mind. All right, our angles, these angles. So let's take our cast concept as we do understand, guys. As you deal with the quadrants, there is no way cast is going to be there. All right, so I'm just going to give a brief on this one. Let us talk about the first quadrant. So for the first quadrant, this is what we are going to notice. So for the first quadrant, these are the angles of what? As we can see. All right, sorry for that. Let's just stop. It's not gonna stop my class, this one. All right, so I knew it's gonna be like this. So anyways, let us do this way. All right, sorry for that case, guys. So I just gonna continue from there. So you see, guys, these things, they do happen. And guys, you ask us to edit. You know, to edit, guys, it's a lot of work, but we're gonna try by all means to make this work. So anyways, I was saying here, what we need is the first quadrant. So in the first quadrant, our angle is what? Theta, 90 degrees minus theta, and we are talking about all being positive. So I'm not gonna talk about everything, guys, the cosec, this, and I'm just gonna talk about one. Then you consider to say the concept of all right, let's talk about these three. The rest, guys, are gonna be taken from there. So it follows that the sine of what? 90 degrees minus theta, because that is what we have in the first quadrant. It's 90 degrees minus what? Minus theta. We have to write it as an acute angle. But we are asking ourselves, we are in the first quadrant. So what is about this part that we are given, our ratio? If we are given as a sine, it must change to a co. which is what? Sine to cos. So it's supposed to change to a cos. But I said a ratio positive is a co-ratio positive. A ratio negative is a co-ratio negative. So the co-ratio, as you can see, is the one that is going to change to what? An acute, because this one is not an acute. So it's going to be cos of what? Cos of theta. This one is positive in the first quadrant. So it means this one is also positive. All right. So what it means the cos of 90 degrees minus theta. It is what? Positive there. But remember, cos changes to what? To sine. So it's going to be sine of what? Sine of theta, a positive also. The tan of 90 degrees minus theta is going to be what? All in the first quadrant, they are positive. But tan changes to what? Its co-ratio or co-function is what? Cot. So that's cot of what? Of theta. So it's the same thing, guys, for the cot and these others that are remaining there, the cot of 90 degrees minus theta. So it simply means when you see cot 90, cot changes to what? To a tan. So it's going to be tan of theta, the same thing for a sec, guys. We cannot finish all this. Sec 90 degrees minus theta, sec changes to what? A cosec. But all of these, they are what? They are positive, all right? So, guys, that is what you're going to do even for this one to this one. That is for the first quadrant. Then we move on to the second. All right, let's talk about the second quadrant. So in the second quadrant, all right, so here our angle, remember we said it's 90 degrees minus theta in the what? In the first quadrant. Our angle in the second quadrant is given as what? 90 degrees plus theta. This is our angle, 90 degrees plus theta. So we want to see the properties of 90 degrees plus theta. It is in the second quadrant. What happens in the second quadrant? It is only sine, which is positive. So it means everything that has a sign in its calculations, it means the same thing, guys. If we say a sign is what? Is positive. Wherever we have a sign, 1 over a sign, remember, it gives us what? A cosec. So it simply means if a sign is positive, also a cosec is positive, because 1 over positive is what? Positive. The rest, they are negative. It means if a cos is a negative, guys, if you say 1 over cos and a cos is negative, it means it's corresponding. Cos gives us what? A sec. That sec that we have, it must be negative. If we say 1 over tan, it gives us a cot, but in this quadrant, it's negative. So it will be what? Minus cot of whatever that we have. This is what I'm trying to say. You're supposed to know your angles, how they are presented. So in the second quadrant, 90 degrees plus theta, it is a sign which is positive. So it means we were going to say the sign of what? 90 degrees plus theta, like this. Guys, I want you to take this. We are saying this is our ratio and it's what? Positive. Its co-ratio, sine changes to what? To a cos. Its co-ratio, which is a cos, because the sine is positive, the ratio also, the co-ratio is also positive. That is our golden rule. The sign of a ratio is also the sign of what? Of a co-ratio. So if our ratio is positive, it means the corresponding co, which is the cos of theta, it is supposed to be positive. It is not about the cos to say cos here where it lies, it is what? It is a negative. No, it is about the ratio that is given to its co. So if this one is positive, this one must be what? Positive. All right, let's go to a cos. You understand me here. Cos of 90 degrees plus theta, this one. Remember, cos is supposed to change to what? To a sine. All right, let's talk about that one first. Cos is changing to what? To a sine. It was supposed to be sine of theta. But you must consider the quadrant. We are in the second quadrant. Cos is what? In the second quadrant, where only sine is negative, cos is what? Cos is a negative. So the sign of a ratio is the sign of its corresponding what? co-ratio. So it means this sign is supposed to carry what? A negative. As this one carries a negative, where it lies, it is negative. It means our sign is going to be negative. That is the concept. So it is the same thing with our tan. The tan of 90 degrees plus theta. You ask yourself where this tan lies in the second quadrant. It is what? It is a negative. So it means its corresponding co-ratio tan changes to what? To a cot. That cot must be a negative. So it must be negative cot theta. This is the concept. This is the concept. So what about a cot? The cot of 90 degrees plus, you just do this, guys, to answer this question. The cot of 90 degrees plus theta. Remember cot. What is it there? Cot, it's what? It's simply from a tan, where we have got it. For us to have a cot, it's from 1 over a tan. So it means if tan is negative, cot is also negative. So in this quadrant that we are talking about, because tan is negative, the equivalent of a cot there is also what? Is also negative. So it means its corresponding co-ratio, remember, cot changes to what? A tan. So it was going to be what? A tan here. But having what? The sign of the ratio is the sign of what? Corresponding co-ratio. So that was the concept there that you're going to ask yourself just like that. So the same thing with the sec, where the sec is being taken from. Where do we take the sec from? Remember, the sec was taken from what? A cos, 1 over a cos. So if a cos there is negative, it means a sec also is negative, because sec it's 1 over cos. It's 1 over cos of this. 1 over cos 90 degrees plus theta, like this. It's a sec. This is the one that gives us this. The same thing, 1 over a tan, 1 over a tan of 90 degrees plus theta gives us what? 1 over tan. Remember, it's what? It's a cot. So 1 over tan is going to be cot 90 degrees plus theta. So the properties of a tan as they were, it is just like we are saying 1 over a minus. So it's going to be a minus. This one will be a minus. If cos is positive, it means it's supposed to be positive. But cos is what? Negative. So 1 over negative, it means our sec is supposed to be also negative. There's no way that you're saying 1 over a negative value, then you get a positive. No. 1 over a negative, you must get what? A corresponding negative. That's how you find these reciprocals, their sign. So to know the sign of a reciprocal, you just take from its what? Its corresponding ratio. If cos is negative, its reciprocal, a sec, is also negative. So what does it mean? What about its co-function? Here, guys, we are worried about what? Its co-function. Remember, sec goes to what? Cosec. We introduce a co. So it will be what? Cosec. So it is going to be cosec of what? The cosec of the acute angle being what? Negative, because here it's negative. Ratio negative, co-ratio also negative. So what about this one? The cosec. What was going to happen with the cosec? All right, this one, guys, I'm not supposed to fill these things for you. You're supposed to know these ones. From 1, you're supposed to fill everything. So I'm just going to fill this one, then you do the rest for other angles. So this is how you do it. Cosec 90. Cosec is from where? Remember, cosec is taken from what? 1 over a sine. 1 over sine. This 9 is from 1 over sine, this one. 1 over sine of what? 90 degrees plus theta gives us a cosec. So if sine is positive, definitely it means the answer is also positive. So it means cosec, it's a positive value because it's taken from what? A positive value. But our major case is cosec changes to what? Remember, cosec changes to what? To a sec. In our case here, it changes to what? To a sec. So it was going to be a sec of what? Of theta as a co-ratio. But we are saying positive ratio, positive co-ratio. So it is going to remain as what? As a positive, just like what we saw on a sine of 90 degrees plus theta. We got positive cos. So it's the same thing with this one. That's how we're going to take these. So I want you to do the same thing. Use this to fill in the third quadrant and so on and so on. Let's just maybe fill one or two. I'm just going to fill sine, cos, and tan. Then you fill the rest because you know that the rest to be taken from this. 1 over sine is cosec. 1 over cos, it's what? It's a sec. But you just have to consider the sine that is there. All right. So I want you to fill the rest. So the third quadrant, this is the quadrant for what? This is the quadrant for 270 degrees minus theta. So if we are given 270 degrees minus theta, this is the quadrant for what? A tan. It is only a tan, which is what? Positive. So it means a sine there is what? Negative. Sine of 270 degrees minus theta. This one, it's a negative value. If we simplify it, we are going to get a negative answer. But as a co-ratio, sine changes to what? A cos. So it was supposed to be cos theta. But we are saying the sine of a ratio is the sine of what? Its co-ratio. So it will be minus cos, just like that. Same thing, cos 270 degrees minus theta. Remember, we are in the third quadrant. Only tan is positive. So it means a cos is what? Negative. So its co-ratio is also negative. Remember, cos changes to what? A sine. So it's negative sine of theta. What about a tan? A tan of 270 degrees minus theta, because of the quadrant where we are, which is the quadrant of a tan, it is going to change to what? A cot, which is what? A positive, because tan is positive in that quadrant. It is the quadrant of a tan. So I want you to use this to find the others, cot, sec, and cosec, using the same principle that I said. 1 over sine, it's what? Cosec. 1 over this, sec. 1 over this, cot. So you can answer the rest. All right, let's move on to the fourth quadrant. So I'm going to explain in terms of these angles only. Then you do the rest. All right, so as of the fourth quadrant, which is the quadrant of what? 270 degrees plus theta as of the core ratios. This is a different presentation from what we had before. So this is it. In the fourth quadrant, it is the quadrant of what? Of a cos. So it means what happens with a sine? Sine there is a negative. Sine of 270 degrees plus theta. It's a negative value. Sine, the sine of this is going to give us a negative answer. But remember, as a co-ratio, sine changes to what? To a cos. So it was supposed to be cos of what? Negative. This one also negative. Sine of a ratio, sine of a co. Just like that. We move on to cos. 270 degrees plus theta. So the same thing. Same thing. It is the quadrant of what? In the fourth quadrant, this is the quadrant of a cos. Cos is what? Cos is positive. So it means its co-ratio is also a positive. Remember, cos changes to a sine. So the sine of theta is also positive because the ratio is what? Positive there. That is the concept. What about a tan in that quadrant? The tan of 270 degrees plus theta, because it's only cos which is positive there. Tan is what? Tan is negative. So it means its corresponding co-function or co-ratio, which is a cot of theta, is supposed to be also a negative. That's how you take this. With this concept, guys, you can answer any question. So I want you to go through typical questions where this concept is used, where the concept is used. All right. So, okay, let me just do this, guys, for a second. I just hoped everything was on the same page. Now I see that it was just one. All right, no problem. So if you are to consider questions, Make sure that you work with each and every part where this is used. It is either we are changing anything. You are given the sign of 50 degrees. You want to change it. It simply means we are going to have it what? Remember, sign changes to what? A cos. So it's a cos of what? 90 degrees minus theta. 90 degrees minus 50. So it's equivalent to cos of what? 40 degrees, where it is needed. The basic part where you are working with the core function of this nature, especially on the solving of equations, you just need to consider this. Unless they have already specified the angle. If they have specified the angle is 270 degrees plus theta, then you have to use this corresponding part that I have explained, depending with each and every quadrant. So this is how you work these angles, just like that. Just like that. So I want you to do as many questions as we can. Let me see if I can just put one example there that we can use. But as you can see, I have managed to simplify, guys, for you as many. I have done as many questions, guys. I don't think I have left anything. The only thing that we can have. All right, let me just present this one. Because I'm not gonna think that don't think I'm gonna have another time to now come back with another exercise. Let me just finish this one at once. You might be given a question like this: prove that. All right, the cos of 90 degrees minus x times the sine of 360 degrees minus x. So this one is we are going to use everything that we learned, everything. So it's a comparison. It's not like a comparison. We are using everything from our reduction to the core function. So this is the type of a question that mostly in your exams you might be given as. So let's see this one. It's a nice question, this one, because it carries everything. Yes, our major concept of the question was on the use of what these core functions. But this type of a question, guys, this is nice, very nice. All right. So let's see. According to this question, we are asked to prove that everything on the left-hand side is going to give us a tan. So guys, without wasting time, you were supposed to write the left-hand side is equal to, you rewrite this as it is. So guys, yeah, because of time, I'm just going to simplify. So you consider each and every part, how it is given. What exactly are you given there? Is it a core function or is it part of our reduction? So as you can see, guys, cos 90 degrees. Once you see 90 degrees, 90 degrees and 270 degrees, those ones which are along the vertical line. Once you see these two angles, 90 degrees, 270 degrees, on your calculations, whether they write sine 270 degrees minus x, cos 270 degrees plus x, once you see the 270 or the 90, you know that, guys, you are back where to this part of your core function. That is where the 90 degrees is there. So these are questions. Whenever you deal of the core function in actual sense, we can say these are the ones which can be written in the form of 90 degrees plus or minus theta, or 270 degrees plus or minus theta, once you see this format. All right. So anyways, guys, I'm not going to waste much time there. So let us quickly check what we are given there. According to this, cos 90 degrees minus x, where does it lie? It is the first quadrant. We saw that 90 degrees minus what? Minus theta. This is the first quadrant according to our core function, this one, 90 degrees minus theta. So we talked about this, guys. Cos changes to a sine, and we simplified this. If you have forgotten, guys, remember, we simplified in the first quadrant, so I'm not going to talk about that much. Remember, cos, core ratio, core changes to what? Sine. And in the first quadrant, cos is positive. So it means also our sine there is what? Is positive. Just like that. The sine of 360 degrees minus x. Is this one a core? No, it's not there. We don't have it there. We are back to the reduction there, our positive angles, that part of our reduction. All right, let me remove this one. It's going to complicate when I want to move in between my pages here. Sorry for that, guys. I was just like, sorry for this. All right, so no problem. Let's go back to our question here. So I want you to see something from our previous part. We had these ones. When we had the reduction, positive, negative angles. We are back to that concept. 360 degrees minus what? Minus theta. Which quadrant are we talking about? This is what we have here, according to our question here. 360 degrees minus x. So which quadrant are we talking about? 360 minus x. We are talking about the fourth quadrant, according to the positive angles. This is where we have 360. So it's for cos. Sine is what there? Sine is negative. So it was going to give us a negative of a sine. So that's negative. This is reduction. Remember, reduction, it is a sine is to a sine, a cos to a cos. This is reduction. It's not co-function where we have a ratio and its core ratio. Sine changes to a cos. Cos to it's different, guys. So do not confuse this part. All right. Reduction, sine remains as a sine, but you consider to say, is it negative or positive? All right. What about cos 360 degrees minus x? Same quadrant. Same quadrant. And this is the quadrant for what? For a cos. Cos is what there? Positive. So not wasting much time. Our cos there is what? Is positive. All right. Everything over what? We go to the denominator. We do the same thing. This is already in simplest form. That is the cos of x as it is. So take note, guys. When you see this 90 minus x, remember our theta is just like theta. This is our acute angle, the x. All right. So let's move on. Sine 90 degrees, 90, 90, 90, there. Vertical, 90. We are back to the core ratios. The sine of 90 degrees minus theta in the first quadrant, we said is going to give us what? Sine changes to cos and it's positive. You are in the first quadrant. Sine is positive. So its corresponding core changes to cos must be positive also. All right. Reduction. We don't have 90 or 270. So we are back to our reduction. Sine of 180 plus x, which quadrant? 180 plus theta in the third quadrant, the quadrant of a tan. So sine is what there? Sine is negative, cos is negative. So it was going to change to a negative sine of x. So take note, sine, a sine. All right. It is only the part of a core which changes to say it was a cos. Look, it's now sine. A core here, a core function, a sine, it's now a cos. But the rest, as long it is reduction, sine as it is, it remains as a sine. You just have to consider to say in that quadrant, is it negative or positive? But these ones which lie or which are taken on the vertical x, these ones, they change because of the situation of how they are presented. So it's another part, guys, that is deep that we need to talk about on another class. They change. Just know that. All right. So anyways, guys, let us simplify. From this case, we can simplify, cancel whatever that we can. A negative sign and a negative sign. Sine. All right. No. This is a cos and a cos. So we are going to have a sine over a cos, which is remaining. So this is the sine of x over the cos of x. And remember, sine over cos gives us what? A tan. And this is exactly what we are given to prove that it is going to give us what we have on the left-hand side. So this is exactly what we have, on the right-hand side. Just like that. So the simplification and the proof I said before lies on the same principle or same concept. How you simplify, how you prove, same thing. It's only that on a proof you are given the answer to say, this is your answer. Simplify, you are not given the answer. All right? So it can be like that. You just have to revise as much questions as you can so that we don't get much problems in our exams. All right, let's just save our last question. The sine of 90 degrees minus theta times the tan of 180 degrees plus theta. So the question there is to simplify. All right, so you're going to multiply to the cosec. All right, the cosec of 180 degrees minus theta, everything over what? So I have this one, guys, I've already explained about this, every part. There's nothing that I did not explain on this one. So we're just going to take our answers. All right, so this is cot 90 degrees minus theta here. So the question is just to simplify. All right, or to evaluate. So using the concept, just like what we had, guys, we need to consider what exactly are you dealing with? A co-function or a reduction as usual. So sine 90, the moment we see 90 degrees and 270 degrees, the part of our vertical line, this part of our vertical line, we are dealing with the core. So this is the part of our core ratios or the core function, this part of these two angles. So we can see that happening. Let us just mark them, or the core here, 90 degrees minus theta. This one is a core. Gain another. There's a 270 here. As long as we see 90 and 270, all right, 270 there. There's this one. So these ones are core. And the rest are reductions, these ones. So, guys, that's just like that, all right? So sine of 90 degrees changes to what? It's an acute angle. So it is positive. It means its core must be positive. All right. Remember, we listed that before. Sine here, positive. All right. Let's go back to this one. The tan of 180 plus theta from our reduction end as a positive angle, it lies in the third quadrant, and that is the quadrant of what? This is the quadrant of a tan. So tan is what? Positive. That's a positive. Tan, just a tan. What about the cosec of 180? Where do I take this one from? I just take it from its consideration. I know that 1 over a cosec, let's say it was cosec of theta. It was taken from what? A sine. Remember, 1 over sine is cosec. So in the same sense, guys, if I'm given 1 over cosec of 90, all right, so this is 180 degrees minus theta. It simply means it was supposed to be written as what? 1 over cos. From those, it's sine. Just 1 over tan, cot, and so on. So it was supposed to give us a sine of 180 degrees minus theta. This is how it was supposed to be like. So you ask yourself, the sine of 180 degrees minus theta is what? Which quadrant? Second quadrant, and sine is what? Positive there. So it was going to change, or it was going to give us what? The sine of theta. It was going to reduce. We're going to reduce it to a sine of theta. That is the concept. So if you want, you can write it as a cosec, because we are saying, guys, this one, 1 over a cosec, this one, it's a sine in our presentation. This one, it's a sine in our presentation. To say 1 over a cosec is going to give us what? A sine of 180 degrees minus theta, when we have it that way. So when it is a cosec, take it from where? 1 over a sine. Let's take it that way now. When it is a cosec, you understand me very soon, okay? So guys, maybe my presentation was just something else, a weird presentation, but sorry for that. So the cosec of theta, it means the opposite now, 1 over a sine, so that we understand each other. Let's work it from a cosec. 1 over a sine. So if I have a cosec of 180 degrees minus theta, it means I was going to write it as 1 over what? A cosec of this is 1 over a sine of theta. All right, sine of, sorry, as it is here, 180 degrees minus theta as it is here. This is the presentation that I'm trying to say. As it is here, to say it's 180 minus theta. So this one is also 180 minus theta. All right. This is a cosec. All right. Cosec, like this. So 1 over a sine. So now this one can be simplified because we know that this one, sine of 180 degrees minus this one, it's what? We are related to that because it's a sine. We are related. We know, all right, this one is a sine, so it's positive there. So you're going to have what? A sine of theta. You are used to that one. So you're going to write 1 over what? 1 over the sine of theta. This one changes to a sine. We have used our reduction. Our reduction has played a role. But what is 1 over sine theta? Just like what we had here. 1 over sine is what? A cosec. So it was going to give us a cosec of theta because sine is positive. It means our cosec also is positive there. So it was going to be a cosec. Yes, you can write it as 1 over a sine. It's up to you. Or you can write it as what? A cosec of theta. Remember, these two are the same. So I'm just going to take this one. A cosec of what? Of theta. This is the equivalent of this one. It is in the second quadrant where sine is positive. So it follows the same way of a sine. It's a reduction. It's not a co-ratio concept. So cosec, we remain with that cosec so that we understand it. If I change it, it will be like, what? Why are you changing now? You guys, no problem. So that is why I just want to maintain the cosec so that we don't confuse each other. But these ones, that is the 270. Remember, co-functions, 270 minus theta. Which quadrant? You're talking about a sec. 270 minus theta here. 270 degrees minus theta. We talked about this to say it is for tan. So it means we have to ask ourselves now to say, where is this sec taken from? If you say sec 270 degrees minus theta like this, where is sec taken from? Sec, it's what? Sec, it's 1 over what? Sec, it's 1 over cos. So if it is sec theta, 1 over cos theta. So if it is sec this one, it means also 1 over cos of that angle as it is 270 degrees minus what? Minus theta. Sec. These are our concept. So if you don't know its equivalent direct, you can calculate it from that way because you are used to what? To 270 minus theta. You are asking, this is a co-ratio. So 270 degrees minus theta is for what? For tan. What does it mean about a cos? Cos there is negative. So this is negative. We change it to its equivalent co-ratio. This is our ratio. So what is the ratio for co? We remove the co because it's already there. So it was going to be sine of what? Of theta, but as a negative. Remember I said the ratio, the sine of a ratio is the sine of the what? Co-ratio. This is the co-ratio. So we are asking ourselves now to say, what is 1 over minus sine theta? 1 over minus sine theta. Remember, 1 over sine is what? It's a sec. So it was going to be what? Sec of theta. So that is the concept. Or you just ask yourself, like I said, a sec, where is it going to be? Oh, so a cosec here. Why am I having a sec? Oh, now this is working with a tired mind, guys. Let me finish with this example. I'll be done with this one. All right, so this is it, a cosec. So we can use that concept. Oh, just go back to this diagram, guys. You see, I was just trying to simplify something that I have already talked about here. So you end up even making those mistakes now. So you see here, we already talked about what? Where we have this angle is what? 270 degrees minus theta. So 270 degrees minus theta, we talked about this, but you just have to ask yourself to say, it's a what? It's a sec. So we have this answer now. But I'm saying another way, we could have said a sec of 270 degrees minus theta from this presentation here. So I'm now giving you the answer that I was saying. Give me these answers that are remaining. All right. So we just take it from the same consideration. It's taken from where? A cos. 1 over a cos is 270. So the same way, 1 over a cos of this. That is what you're going to have. 1 over a cos of what? a cos of 270 degrees minus what? Minus theta. This is how you're going to have it. But as you ask yourself this question, you're saying, that cos there, it was what? That cos of 270 degrees, it gave us a negative sign. A negative, because it was negative. So it also follows that this one, it is a negative value. So its answer is a cos. Remember, sec changes to cos. So it's going to be cosec of what? Of theta. Negative, also negative. So you can use this concept, or you can use this one. If you understand this, 1 over this, you use the co-function of this one. You know it's negative what? Negative sine theta. And 1 over negative sine theta, 1 over sine is what? It's a cosec. So it will be negative cosec, just like that. So that's how you answer these questions, guys. It can be just like a little bit hectic, but it's not that much. Revise also the trigonometry part that I worked on grade 11 mathematics, so that you can add some of these simplifications even from grade 10 mathematics. It can also add up to your calculations to figure out all this part. All right. So we saw that this will change to what? A negative cosec of what? Of theta times, what about cot 90 degrees minus theta? So we'll not waste much time. We talked about this. Cot of 90 degrees minus theta, we said is what? It's tan of theta, as it is because it's a positive angle, but cot changes to what? Tan. Remember, cot changes. We remove that one. It's now a tan. So that's tan of theta. Just like that. So we are going to simplify. Wherever it is possible, you can cancel because that's a product, a tan, a cosec, and a cosec. So we are remaining with what? A negative, here a cos. So cos divided by this negative is going to be negative cos of theta at the end. So this is how we're going to have our final answer at the end. So I want you to use this presentation with the previous calculations that we had together. Use this in hand, like all in hand, to answer your questions, simplify in as much as we can. So it can extend. There are so many things that we're going to talk about. So we just have to be very patient. We're going to talk about other part of the trigonometric identities, the special angles, the compound angles, the double angles, and how to solve our trigonometric equations. Then we can say trigonometry is done. But do not wait, because there's another class that I have explained about like a rough view, like just a basic view of the trigonometry concept, or like almost everything in that video. So you can use that video for now, but as we are working with a stage by stage or a separate part of this trigonometry, you can just be watching that one. It has some of the information which is important, but do not forget to watch these videos because we are adding as it is on our revised curriculum. So any question can be taken from these examples. This is our revised curriculum. So that is it, guys. Till we meet again.